So starting with laws of motion, okay, these are called Newton's laws of motion. There are three laws. First one is called law of inertia also, otherwise the normal names are Newton's first law of motion, Newton's second law, Newton's third law. But first law is also known as law of inertia because of its statement. It states that according to Newton's first law of motion, an object continues, you can write it down side by side, an object continues to be in state of rest or state of uniform motion unless and until an external force is applied on it. Now that makes sense for inertia as well. The law states an object remains in its state of rest or state of uniform motion unless and until an external force is applied on it, right? And this is what we studied in inertia, that inertia is the natural tendency of object to remain in rest, or or in the position of rest or in the position of motion, right? So inertia are of three types: inertia of rest, inertia of motion, and inertia of direction. So this law of motion, that is law of inertia, is applicable, that is Newton's first law of motion, is applicable on all sort of inertia, that is inertia of rest, motion and direction. So I'll repeat the statement again. It states that an object continues to be in its state of rest or motion or uniform motion unless and until an external force is applied on it. This was Newton's first law. Now before we start Newton's second law, we have to study about another term called momentum. Now what exactly this momentum means? See, the term is momentum. To understand the physical significance of it, consider an example. There is a bicycle which is moving with 80 kilometers per hour, 80 kilometers per hour, and the bicycle with this 80 huge velocity, it is going and striking a wall, okay, a normal brick wall. What will happen? Nothing will happen to the wall, but some damage might incur to the bicycle, right? But if there is a truck which is moving at 80 km per hour, goes and it strikes the wall, what will happen? This time the wall may break. So what exactly is the difference between bicycle hit and the truck hit? In both the cases we had the same speed, that is 80 km per hour, but in case of truck, the mass of truck was way more than the mass of bicycle, right? So that is where the quantity of motion comes into play. Momentum is the quantity of motion contained in the body. Quantity of motion, how much motion is involved in the body, and it involves both of the terms, that is mass as well as velocity. So momentum is actually product of, it is denoted by P, it is product of mass and velocity of the body, and it is understood as, it is defined as, definition is this, it is the product of mass and velocity, but it is understood as the fact that momentum is basically the quantity or measure of quantity contained in the body, right? That is momentum. Now the second law states that, I'll write down the whole thing because we have to find a mathematical expression for it as well. Second law of motion states that rate of change of momentum is directly proportional to external force applied on it. So rate of change of momentum on a body is directly proportional to, I have written down the main points, complete it out. Rate of change of momentum or force applied on a body is directly proportional to rate of change of momentum on it, or vice versa, rate of change of momentum on a body is directly proportional to external force applied on it. Now let's find the mathematical expression for it, what exactly this law states. We have a body of mass m which is moving with a velocity u meter per second, right? After t time, due to application of a force on this body which is F force is what? Newtons. But this is where the concept of SI unit comes into play. Now this body is acted upon by this force of F units, and now body after t interval is moving with velocity v meter per second. So what was the initial momentum? Let us say P1 at this point is initial momentum. Momentum is product of mass and velocity, so it would be m into u. Whereas here momentum would be m into v. According to this law, rate of change of momentum, force is directly proportional to rate of change of momentum. How do we calculate change? Suppose change is always done by final minus initial. I was saying that suppose your weight is 80 kg now and after some time your weight is 60 kg. So the change is final minus initial, right? This is how we find the change. Change of momentum is final momentum minus initial momentum, that is P2 minus P1 upon rate means time. What is P2? P2 is m into v. What is P1? M into u over t. So this thing is giving me that force is proportional to, I am taking m common out, v minus u upon t, and hence force is proportional to, this is what, v is equal to u plus at, v minus u is equal to at, right? Take t there, you will get v minus u upon t is equal to a, the acceleration. This is what the definition of acceleration was, rate of change of velocity. So m into a. This is the mathematical expression of this law, that is Newton's second law. Force is proportional to mass into acceleration. Now to put equality sign, I have to write a constant k, right? This is also a valid equation. Now mass, SI unit of mass is kg, SI unit of acceleration is meter per second square, right? So SI unit of force is so chosen that the constant's value k comes out to be 1, and that is why we get, I hope you have noted it down, right? So okay, I leave that thing and I write it here. I just told you that in SI system, the SI unit of force is such a way chosen that the constant's value comes out to be 1. So force is mass into acceleration. This is the final format of Newton's second law. This is the expression which we have derived from the second law, where SI unit of force is called newtons. 1 newton is 1 kg into 1 meter per second square. So let's define 1 newton. When a body of 1 kg is moving with an acceleration of 1 meter per second square, then force acting on it is said to be 1 newtons, right? Try to paraphrase it in another way. When it is 1 newton of force is that amount of force which when applied on a body of mass 1 kg will produce an acceleration of 1 meter per second square on it. See, so anyways you can derive or you can formulate this expression. So this is the formula, force is equal to mass into acceleration. So now we have the cause of acceleration, because up till this point those equations which were v equals to u plus at, s equals to ut plus half at square, v square minus u square is equal to 2as. Up till this point we had the equations of motion but we never had the cause, but now we have the cause from this. Suppose a body of mass 10 kg is acted upon by a force of 20 newtons. So from 10 kg and 20 newtons, using this formula I can find out the value of acceleration, and using this value of acceleration in these three equations I can find out anything else. So now we have the cause of the motion as well, and that is how we are going to use it with these three formulas. This is Newton's second law.